So here in this chapter, we're going to look at inverses. When you hear the word inverse, you should think of just opposite. What is the opposite of my function? Now note inverses is denoted by being raised to a power of -1, as you see there in the red. So whenever you see this -1 here in front of my f or my function, that means it is the inverse of that function. Now we have a couple parent functions, and some of these parent functions are inverse of one another. The first is quadratic, x squared. Its inverse, its opposite, is the square root of x. Cubic, so x cubed, the inverse is cube root. Logarithmics, its inverse is exponential. Linear equations is its own inverse. Rational functions is also its own inverse. So it's up to you. You'll need to memorize the relationships between the parent functions and their inverse. You'll need to know that quadratic is square root, cubic is cube root, log is exponentials, and linear and rationals are their own inverse. So quickly, let's look at some properties of inverses. What make them inverses, what makes them opposites. If I look at the table here, my function, x and y, what do you notice about the difference between the function and its inverse? If you say the values of x and y are flipped, then you are correct. What's the opposite of x and y? Well, it's y and x. So if I look here at the value of x equals 0 and y equals -7, then its inverse, x is -7, y is 0. So its coordinates are flipped with inverses. Now that corresponds to graphing. If you flip the coordinates, then you flip the graph. Note that the graphs on all inverses will get flipped over the linear function, y equals x. As you see, it almost looks like y equals x is a mirror, and this function is flipped or reflected over that linear function. So when we flip the coordinates, we also flip the graph over y equals x. And if we flip the graph, then that also means we flip the domain. So notice the difference between these two. The domain and ranges are flipped. If my domain is from -2 to infinity, then my inverse, that's going to be its range. And if my function's range is 0 to infinity, that's going to be the inverse's domain. So domain and ranges are flipped. Now the big takeaway from this chapter is how to solve for inverses, which I'd like to say inside outside. So let me first take this quadratic, x plus 2 squared minus 4. Now think, what is the inverse of a quadratic? Well, if you said square root, you would be correct. Now, what about the numbers inside? We've seen before that these are transformations. How do these transformations work with inverses? Well, this is why I say inside, outside. Remember, opposite is the meaning of inverse. So if you look here at x plus 2, this plus 2 inside my square, what's the opposite of inside? Well, that is outside. What's the opposite of plus? Well, that is minus. So that 2, which is inside my square, is now going to be outside my square root. And the value, the signs, will be flipped. Now look at the -4. It is outside my square. What's the opposite of outside? That is inside. So it's going to be inside my inverse, inside my square root. And the opposite of minus is plus. As you see here, the numbers and the signs will flip. They are opposites. They will be changing. That's why I call this inside, outside. Let's look at this cubic. X minus 3 cubed plus 1. What is the inverse of a cubic? You should have said cube root. And what do we do with these numbers? Well, this -3 inside goes where? Well, that goes outside, and it becomes a +3. This +1 outside goes where? Well, it goes inside my cube root. The opposite of plus becomes minus. So the inverse of this function is cube root of x minus 1 plus 3. Last but not least, rational functions. Like I said, the inverse of a rational function is a rational function. Opposite of flipping a fraction is still a fraction. So now what do we do with this -5? Notice this -5 is inside my fraction here. So the opposite of inside is outside, and the opposite of minus is plus.